Okay, part 2. 17, 18, and 19, you're asked to solve. And here's a graph. And this is new, graphing to solve these quadratic equations. You've done it a couple days, but it's still kind of new to us. Most of the time we've been factoring to solve. Turns out 17, 18, 19, two of these you can still just factor to solve. So 17 can be factored to solve by factoring out the GCF. And then you just take x out, so you get x times x plus 2 equals 0. So x equals 0, set each factor equal to 0, so x equals 0, x equals -2, and you're done. And number 19, you just factor to solve. This is also factorable, so you can factor to solve that, and you'll use your diamond. Now number 18 is not going to be factorable. I can take out a -1, and so I have 2x squared minus 4x minus 2 equals 0. And when I put this into my diamond, I get -4 up here and -4 down here. And there are not two numbers that will work for this diamond. So in order to solve this, we'll have to graph it. There's two choices, factoring or graphing, and these two can be factored. Done very quickly. Let's graph this to solve. Okay, first thing we have to do, since we can't factor it and get the x-intercepts, we're going to do the AOS method, which I like to call it. It's x equals the opposite of b over 2a. And then we'll use that to find the vertex. And then we'll use the y-intercept, and then we'll use any additional points we might need to graph. So here's our function. Let's square it so we can keep referring back to it. X equals the opposite of 4 is -4 over 2 times a, which is -4. So that's 1. X equals 1. I'll make a graph, and since I know I only have to graph 1, I'll make it as big as I like. X equals 1 is right here, so I'll draw a dotted line to put in my axis of symmetry. It's kind of hard to see on this dark paper. Should probably be using a different color. Maybe this will help. Maybe not. Okay, so the axis of symmetry is going to help us to plot the rest of our points. Now the vertex is on the axis of symmetry, so x equals 1 can be put into the function to solve for where the y value will be for our vertex. -2 times 1 squared plus 4 times 1 plus 2 equals. That's -2 plus 4 plus 2 is equal to 4. So the vertex is at 1. So let's see, this is -2 plus 4 is 2. That's 4. So the vertex is at 1, 4. 1, 1, 2, 3, 4. This coefficient, the leading coefficient, is negative, so this parabola will open downward. And so that's what we'll hope to see. The y-intercept is 2. Remember, it's equal to c. So that's right here. And if you can't remember that the y-intercept is equal to c, then you can just let x equal 0 and put 0 into the function. And whatever value you get out will be your y-intercept. So x equals 0 would be -2 times 0 squared plus 4 times 0 plus 2. That's 0 plus 0 plus 2 is 2. 2. So our y-intercept is 2. Okay, that can be reflected across the axis of symmetry Our parabolas are symmetric. There it goes. Our additional point, let's choose a point to the left or the right of what we have. Let's choose positive 1, 2, 3, positive 3. Okay, I'm going to do it over here. X equals 3. I'm going to put it into the function. Negative 2 times 3 squared plus 4 times 3 plus 2. That's negative 2 times 9 plus 12 plus 2. That's negative 18 plus 12 plus 2. I'm doing this the long way. Negative 6 plus 2 is negative 4. When I put 3 into the function, I get out the point negative 4, the value negative 4. So our point is 3, negative 4. 3, 1, 2, 3, 4. That's my additional point, and I can mirror it. 1, 2, 1, 2. And I'll draw the parabola. Now I was asked to solve. So for number 18, I'm looking for the places where this curve crosses the x-axis. Remember, these are the solutions. So it looks to me like x is between, let's see, x is between 2 and 3, 2 and 3, and it looks like x is between negative 1 and negative 2. I don't know exactly what they are, but that is closely approximating where the solutions are on the x-axis, where the curve crosses. Somewhere between those 2 points and those two numbers, negative 1 and negative 2. Oh wait, that's 0 and 1. That's 0 and negative 1. Whoops. Between negative 1 and 0. So this spot right here, here's our x-axis, our y-axis. So it's between 0 and negative 1, and it's between 2 and 3. Okay, so that's a little heads up on the homework. I hope it helps, and I'll see you tomorrow.